Well, we took the old black one home and we come back with a red one. This is our next project. This is a Honda TRX350TE for a two-wheel drive manual shift, and yep, she has whacked a few things. It is in the condition that you see it in, and it is just a little bit rough, but it has good tires on the back. But the front end leaves a lot to be desired. Now this thing come down with a curious case of no spark, and that's the reason it's here, because it doesn't have any spark. Otherwise, it had kept being driven until something else happened. But you can see this thing got shortened by about 3 or 4 inches here on the front, and it just shoved everything back. Yep, she's whacked a few things. Cows, fences, trees, you name it, it has whacked it. All right, we're gonna get going on this thing. And when I hit the start button, nothing happens. No sparky. Well, what are the reasons this thing could have no spark? Well, we have a crankshaft pickup sensor down on the stator. Then we have wiring. We have a CDI box. And then we also have ignition controlling stuff like the key switch and also the stop switch up on the handlebar. They control it to shut it down, and then we also have ignition producing, and that's going to be our stator and our battery, I think. No, I think it's a start without a battery. So stator and a source coil, which is all part of the same thing down by the flywheel. So let's go check and see if we have, let's check our crank position sensor and see if we actually have voltage coming out of it. All right, now in order to do this, our best bet is going to be to remove this foot liner, inner foot liner, fender liner thing, this all right here. Now, all the push pins are out of it, and I've taken out the other bolts. We just need to pull these two with the foot pegs, set the foot peg aside, and its screws, and remove this sweetheart. Now we can get in here a little easier. Oh, and guess what? This also has Honda-itis, where the brake pedal doesn't move because it's all seized up in here. So we get to do that as well. And probably a bunch of stuff with the rear brakes. The front brakes seem to work. And this thing steers really hard. I don't know if it's in the ball joints or where the issue is, but we're going to find that one too. All right, we're on the right side of the bike, and there's a row of plug connections here. And they do several different things. There's a reverse switch in there. There's a neutral switch in there. And also, not sure what that one is. We could chase it out and figure out what it is though. I think that's the carb heater. And this is the one we're after. This is the stator connector. You know, I power washed the crud out of this thing, and look how clean she is as soon as you pull the first cover off. Isn't that lovely? This thing was pretty darn covered. All right, let's disconnect this. There's a tab right underneath where you can't see. We'll pull that tab and pull this connector out. Check and see. We don't have any green crusties in there, so that's good. And we'll go ahead and set up our multimeter where you can almost see it and I can see it. You may consider this wrong, but I think it's more important that I see it. Can you see it? That's the question. Can you? Yeah, maybe. Right now it says 0.L. And we're going to see what our resistance is in our crank position sensor. $337 ohms. That don't seem too bad. Let's check it to ground real quick. Just gonna put the other end on the engine ground. That side's ground. And that side is 0.1, 0.2. I think what we need to do is we need to get us a peak voltage meter and put it on there and see what kind of voltage it's actually producing. We have a peak voltage meter adapter here. We're just going to pull our leads. We're going to set this sweetheart in line with the black going to common and the other one going to voltage, like so. And then we'll plug these back in here. And then we're going to go to, I can't remember, but it's voltage DC or voltage AC. Can you still see that? It's getting quite a ways, pretty wonky. Yeah, I guess. What about if we do this? Is that better? Maybe. All right, I want to front probe these like you're never supposed to do. Like so. I'm going to turn the key on, and then I'm probably going to screw everything up by trying to reach the starter button. I'll turn the handlebars, switch hands, and whack that button. Well, we're getting about 6 volts, and you know, that's just not too bad. I think this is supposed to be on DC. 6.5 volts. That's not too bad. Well, we'll plug that back in. Hey, while we're at it, let's go ahead and check our stator wires real quick and see what we got as far as voltage there. We'll check between 2 legs here. 7.5 volts cranking. 7.5 volts. Now we'll go between these 2 legs. I think that stator's going to be okay. I do. We can also check, we got our peak voltage meter in line. We're not going to mess with it. We'll plug this back in, and then we'll continue on trying to figure out what the heck is wrong with this thing. Because that's really what we want to know. Next thing you need to do is check, let's see here, let's check our wiring, our peak voltage at the actual ECM connector. Let me prepare for that, and then we'll do that. Now our ECM sits up here by the front shock. I removed the inner fender. I already had the other fenders off of this thing, and trying to see how much crash damage there is on this, and there's considerable crash damage on it with the front end, the rack, and all that stuff. But anyway, back to this. I had to spray some WD-40 in here to get these to actually loosen up off the posts. There's just so much dirt and grime in there. We're going to flip this baby around and figure out what wire colors we need. In this case, we are going to need, what color are they back here? Green, white, which is that one right there. And is it blue, yellow? Blue. Yep, blue, yellow. Green, white, and blue, yellow, which is this wire right here and this one up here. We're going to get some back probes and stick in there and see what we got. I'll tell you what, let's just disconnect this and see if we got any kind of conductivity in here. Got any green crusties or anything growing? No, connectors look pretty good. Well, hell, now we can front probe it. That'll be even easier. See if we can get all this set up where everybody can see. I won't lie to you. That's more important than I see. But for entertainment purposes only, we'll see if we can do this otherwise. We need to go to there and to there. Now the trick is to get all this held in place while I turn the key and hit the starter. Yep, we got a good signal all the way up to our ECM. And that's just a crank position sensor. We need to check some other stuff out on this sweetheart as well. Let's see here. I'm going to go get a wiring diagram for this sweetheart and see exactly what else we need. I know we need to check our circuits as far as our controlling side. Considering this took a whack on the front, it is possible we have some wiring damage. Now, it ran a long time after the crash. That was 3 or 4 years ago. And they just were running this like it is. But I don't blame them. It still ran. Alrighty. Our ignition component wires are these, and they come down there and plug in somewhere. Let's just lay that over there out of the way. Yeah, that's pretty good. See how clean I got this? I mean, I washed the crud out of this thing. I actually went to the car wash because it's kind of covered in a lot of cow poo, and my wife really didn't want that in the driveway. So I went up and washed it at the car wash. I think this is probably our ignition wires. So we figure out which wires actually run this thing and which ones shut it off. We get the black as ground. We got a pink. And then we have a variety of reds here. A red and possibly a red white, red black. Red, black, and red. That's probably going to turn the thing on, supply power through the key switch. So I'm going to guess that pink or black, one of the two, is our kill wire. I don't know which one for sure. I really should know that. This one goes up to the handlebar switches. Comes over here, it goes to the brake light, has another brake light, and also goes to the handlebar switch over on this side, and curiously, it has a kill in it. Alrighty, I went and printed off a ignition system part of a manual, and let's see what we got here. Now, I already know that some of our wire colors do not match what's on here, so we're going to have to pretend like it does, and we'll work our way through that. So, we have our ignition switch on, and we have our kill switch on, and according to this, well, I know that right now, we're going to have power on, looks like a light blue. Is that what we got? Yeah, there's battery voltage, and it's coming through on a blue-red. Yeah, for some reason, our wiring diagram does not match. That is no good at all. Because according to this, we should have power in 2 spots. On a black-white, which seems totally wrong to me, but we'll check that one too. This is our black-white down here in the corner. This one, and go to ground. And we're not getting anything to speak of there. Make sure we got a good ground. We do. Nope. 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 So the only one we got power on right now is it black, white, or blue, red? I think it's this one that has power. That one has power. This one does not. That's our black, white. The ignition stop switch, it should be good. Let's check our, see if we got a 10 amp fuse that is junk. We'll let this down a ways, and we're going to check some fuses. We're going to back up and do what we should have done to start with. Check fuses. This is our fuse box back here. If we squeeze these and pull, the cover should come off. Well, one end did. There we go. And then turn this over, and we have a 10 amp ignition fuse. Well, isn't that interesting? 30 amp main, so it goes this way. Our main fuse should be good. Let's just do some checking. Can you see the meter, or have I got a good enough glare on it that nobody can read it? Alrighty. Current conditions withstanding, that's about as close as we're going to get. So we're going to take our negative wire to its spot, and we're going to check our fuses here. 1208. 1208, next to nothing, even more nothing. Things that make you go, turn our ignition switch on, and then we should be able to power up our 10 amp, our 10 amp ignition fuse should be powered up now. So we'll go there, and in our cap, ignition is the first one, which is this one. Got 12 volts there. Ooh, why, looky there. Why did it pop a main, or why did it pop an ignition fuse? That's a weird one to pop. Let's see if it really is. Indeed. Indeed, it is done. I don't know if you can see that or not, but if you can't, you have to take my word for it. Hopefully, some of that was in focus. So let's pull our 10 amp fuse out of here. Yep, it's good. And see if it immediately pops or if it takes a while. Yeah, it didn't immediately pop. Now then. 12 volts there. 12 volts there. Let's see if we got a spark. This would be a hell of a deal if all it was a blown fuse and we're chasing stuff all over the place. Yeah, well, sometimes that's the way it goes. Let's find our sparky wire. Bring it up here. Crank the handlebar so I can reach the start button. Great. Now then, there we go. We'll put that back on there if we need to. Still no spark. Let's plug our CDI back in, or our ICM, ignition control module. We're more likely to have spark, or pop a fuse, one of the two, with this thing plugged in. All right. You see that? That's amazing. We now have a spark again. Now the real question is why did the fuse blow to start with? Now you have to ask yourself, when you're dealing with an old quad like this that has been smacked on the front pretty hard and run very hard, what could possibly go wrong? Well, more likely than not, it's going to be a wiring issue down here or up on the handlebars. So let's start down here. Let's get our meter set up so I can tell when it loses power. And we'll do a little bit of wiggling, very slow like. See if we can make anything happen. This has 2 screws in it to hold it on, so I'm going to take those out so we can get under there. Working down at the bottom down there was pretty fruitless, so let's come up to the top, pull this cover off, and see if there's anything weird at the handlebars. This one comes up here, and it also has the wires for the reverse, neutral, and overheat light, hot engine light, in it as well, so it does a lot of stuff. I'm going to go look at a wiring diagram and see what all this ignition fuse powers. Alright, the only wild card on this circuit that remains is this. This is the air temp sensor, and it is for the carburetor, carburetor heater. Now this thing should not have continuity now, so the circuit is open. However, this thing stalled and died back when it was cold. So I'm thinking that there's a problem in the carb heater circuit. And I'm pretty sure of it because I've checked everything else. So what we're going to do is whenever it's warm, this thing has no continuity. Hey, God, it's not in great shape, is it? It has no continuity. But whenever it gets cold, below 45, about 45 degrees or less Fahrenheit, then it makes contact and it turns the carb heater on. So what we're going to do is we're going to disconnect this and just leave it disconnected. That way the carb heater does not work. And that will keep our system from blowing a fuse whenever it gets cold outside. Because power comes to here first, then it goes back and goes on to the carburetor heater. So it all heats through this. And so that's what we're going to do. We are going to eliminate this carb heater sensor, temperature sensor, and that should take care of our fuse blowing problem. Now, since it's not cold outside, and I'm not going to go to a ridiculous amount of trouble to cool this off, we're guessing at this. But we know we have spark now, and we know that the rest of the system is good. So this is the wild card. So we're simply going to disconnect and remove this thing and leave this alone. And that will make sure that we don't have any issues as far as the, there we go, the temp sensor whenever it gets cold. So I don't think the problem is here. I think the problem is on down the line at the carb heater. We've got pretty good healthy spark still. So that problem is solved. And we got spark. That's good. Somebody replaced a coil in this needlessly. There's nothing wrong with the coil. There's never anything wrong with the coil. I bet 20 coils are replaced on these for every bad one. So, you know, it is what it is. All right, well, that's the diagnostic electrical system. As silly as it is, it's mostly just a fuse that was popping because of a carb heater. Never thought the carb heater would have been powered off the ignition circuit, but it is. So, we got spark. Hey, let's see if it runs. Let's do that. Alrighty, we got our spark plug wire back on. Our key is on. Not too bad. Now it's going to die here in a second because there's no gas hooked up to it, no fuel tank. Listen to that. This thing has been ran hard and very little care taken of it throughout its entire life, and it still sounds good and doesn't smoke a bit. That's pretty impressive to me. It is a Honda though, so the whole thing might fall down around it, but that is going to keep running as long as it gets clean air, clean fuel, and an oil change every 5 or 6 years or so. Keep oil in it, keep the filter clean, keep the fuel clean. They just run. Not a bad machine. We'll take it up next time whenever we check out those ball joints. Hey, thanks for watching. God bless.